Power density spectrum. If you consider one random process, I am considering one random process. So I am assuming this is the random process, just assumption only, x of t. So the equivalent random process x of t is, this is the equivalent random process x of t, and then what is according to Fourier. So what is the frequency domain equation for this is x of t is x of omega equal minus infinite to plus infinite x of t multiplied with e power minus j omega t dt. So this is the frequency domain representation for the random process x of t. According to inverse Fourier, so x of t time domain representation is x of t is equal throughout 360 1 by 25 minus infinite to plus infinite. X of omega is here only, x of omega e power j omega t minus j omega t, take it this side, then e power plus j omega t d omega. So this is the frequency domain time domain representation, and this is the frequency domain representation for the given random process. For the same random process, what is the energy? Energy can be defined as denoted with, energy can be denoted with P of E of, denoted with E of t, can be defined, that is equal square of the time domain signal x square of t dt. In the form of frequency domain, we can write it as, that is 1 by 25 minus infinite to plus infinite square of the random process d omega. So this is the energy. Coming to the average power, from this only we can define the power density spectrum. If we divide with 2t, we can get the power spectral density. So I am assuming here just energy for the power spectrum, energy for the random process is minus infinite to plus infinite 1 by 25 minus infinite to plus infinite x of omega whole square d omega. If it is non-periodic, we can write it as that is and average power can be defined. Average power for the same random process x of t. So can be defined as, that is Px x of t can be written as, if it is non-periodic, we can write it as limit t tends to infinite 1 by 25 and minus infinite to plus infinite x of omega whole square by divide with 2t. We'll get that is power density spectrum. And we can assume this is equal Px of average power can be defined as 1 by 25 minus infinite to plus infinite Sx of omega d omega. Here, to simplify this, he is assuming this total part. Let Sx of omega is equal limit t tends to infinite, 1 by 2t mod, that is average of expectation. We can write it as average. While taking average, we need to add average expectation x of omega whole square by whole square. So this is the power spectral density or power density spectrum for the given random process x of t. Explain again. Here I am considering this is an random process. What is this is the equivalent for random process x of t. So what is, according to Fourier, what is the frequency domain equation, and what is the time domain representation for this? What is the energy for that in time domain representation as well as frequency domain representation? And finally, we need to write the power for this same random process. If it is non-periodic, we can write it as limit till infinite times. So it can be right. So this is the simplified power density spectrum. Thank you. If you have a doubt, you can send to me.